Hey guys, looking at characteristics of linear functions. This is lesson 4.3 and here are some additional examples to help out. Alright, so number 1 says, for which two functions does f of x approach infinity as x approaches infinity? Explain your reasoning. Alright, to save a little time I went ahead and graphed these. So f of x I put in red. So I started at positive 3 with my y-intercept and I went up 1 over 4 with my slope to graph that line. Alright, g of x I skipped because negative 8, I didn't make my graph big enough. So I can't graph that one, so we're going to try to answer this question without graphing that one. H of x is in blue, has a slope of 2 over 1 because your i's overrun, and a y-intercept of negative 1. So I start at negative 1. Rise 2, run 1, and I graph that blue line is h of x. Alright, so our end behavior talks about what happens as we go. This is our x positive, this is our x negative, this is our y positive, and this is our y negative down here. Alright, so when I look at the function notation, I have to remember that I'm just looking at what is happening to the line as it goes in that direction. Alright, so this says as f of x goes positive, okay? So that means my y is going up as x goes up. Alright, so x is going up in this direction and my y is going up. So it says for which two functions does this happen? Well, we got lucky. The two I graphed, this one's going up to the left and towards the y, so it's going up. This one's going to the right and up. So the two functions would be f and h. Alright, then the next two say determine whether each function is increasing or decreasing on the interval 2 to 5. Alright, so these are linear equations. These are continuous functions. This one has a positive slope. So I know from left to right, it's going in this direction. And it's continuous with arrows. This one goes in the negative direction, just like this, because it has a negative slope. Alright, so this says on the domain 2 to 5. So it just would mean we're going to take out just part of the domain. But if it has arrows and it goes continuously, it would be increasing on the whole interval. It doesn't matter if it's on 2 to 5 or if it's on the whole thing. So we can safely say that this one is increasing and this one is decreasing. So again, increasing if it goes up from left to right, decreasing if it goes down from left to right. Alright, graph each function and describe the end behavior. Alright, so we're going to graph f of x equals negative 5 plus 1. So let's put 1, our y-intercept, on the graph first. Again, this should be reviewed from 8th grade standards, but it's always good to review. This is your slope, so it's going to go down 1, 2, 3, 4, 5, and then positive 1. Again, if you want to go up 1, 2, 3, 4, no, I can't go up 5 because I didn't make my graph big enough here either, but you can sketch the line. Let's see if I can sketch a line here. Alright. And my line would go in both directions with an arrow. Alright, then it says describe the end behavior. So you have to watch these because it says graph and describe the end behavior. So if I look at this for number 6, alright, my end behavior, I'm always going to write my end behavior as f of x does something as x goes positive, and f of x, my y's, do something as x goes to negative infinity. Alright, so basically this is saying when x goes positive, so when x goes positive, here's my x positive, the line goes down, so it's going to negative infinity. Alright, now it says as x goes to negative, so here's x negative, going to the left, the line goes up, so it's going to be to positive infinity. Alright, so number 7, let's graph number 7. It says positive 4, and I have a slope of 3 over 1. All right, when I have a slope of 3 over 1 and my graph's not big enough, I can go 1, 2, 3, and back 1. 2 negatives make a positive, and you can tell it's still a positive slope because it goes up from left to right. So let's use those 2 points to graph that line. And then again, it says describe the end behavior. So very similar to the other one. So f of x does something as x goes positive, and f of x does something as x goes negative. All right, remember x is our independent variable, so we always know that x is going positive, x is going negative over here. So basically this says, okay, when x goes positive, what does y do? It goes positive as well. All right, and this is when x goes negative. So when x goes to the left, what happens? It's going down. So it's going negative. And with arrows, that's why we use the infinity, because the arrows means it's going to keep going. Okay? All right, this says determine whether each linear function is increasing or decreasing. All right, we know this comes from our y values because our y-axis is our vertical axis. So you can tell when it's increasing, it's going up. When it's decreasing, it's going down. So even though this is a table of values, I can look at my y values, 4, 3, 2, 1. Well, I know that's decreasing because my y's are decreasing. Here I've got 80 up to 192, so I can see that my y values for this function is increasing. Pause this if you need to take notes. We're going to keep moving on to the next examples. All right, sketch a graph of the linear function with the given characteristics. Then write an equation for the function. All right, for number 10, it says I have a 0 at 2. So I'm going to put a point at 2. Zeros are always on your x-axis. And a slope of negative 2. So I can go down 2 over 1, or I can go up 2 back 1 and use that to write an equation. If I go up 2 back 1 again, that gives me my y-intercept, and then that way I can easily write that in slope-intercept form using my y-intercept, which is always the point that crosses the y-axis. So let me finish graphing it. I kind of get ahead of myself sometimes. All right, so I'm going to have this going down through there. And then for number 10, I've got a y-intercept of 1, 2, 3, 4. So my b equals 4. And it gave me a slope of negative 2. So I can write a function as y equals m, which is my slope, x plus b. All right, this one has a 0 at 5, so I got a 0 at 5, and I have a slope of negative 1, which is rise over run, makes it negative 1 over 1. So I'm going to rise 1 and go back 1. Got to have that negative slope, so I got to have one positive movement and one negative, up and over. And again, I worked my way back to get to my y-intercept because that's the easiest way to graph a line. So I can say there's my equation graphed. Now I have a b. I have my y-intercept, which is my b, at 5. And I can say y equals my slope, negative 1, times x plus 5. If you want to put a 1 there, that's fine, but the 1 is assumed when there's no number there. All right. Determine the zeros of each linear function. All right, let's start with the equation. F of x equals 5 x minus 1. All right, so there's a couple ways to do this. If you want to graph it, you can, but you also can say, you know, solve for x when y is 0. So let's look at it that way first. So let's say f of x equals 5x minus 1. And we're going to say let y be 0. So I'm going to add 1. 5x equals 1 and divide by 5. So x equals 1/5. And that would be your 0, or that would be where it crosses the x-axis. Okay, so for 23, x equals 1/5. And just for the sake of time, we're going to go ahead and move to this one and do the same thing. So let's say g of x equals 4x minus 2. We're going to let y, or g of x, equals 0. And then we're going to solve for x. So we got 4x equals 2. Divide by 4. X equals 1/2. So x equals 1/2 is the 0 for that function. All right, so for the table of values, all I have to do is find when y is 0. See where we plugged up 0 in for this here? So when y is 0, x is 2. So this is the 0 of my function. So 2 would be the 0 here. So x equals 2. And then for this one, you can see wherever it crosses the x-axis is your 0. So here it would be -2. So lots of ways to find the 0 of your function. First, you could plug in 0 for y if it's an equation. If it's a table, find where 0 is in the y column. And if it's a graph, find the x-intercept, and that gives you the 0 to your functions. All right, let's try to get one of these done before the time runs out. So identify the 0, the y-intercept, the maximum, and the minimum of the functions. All right, so the 0 of the graph would be 5. If you want to write it as 5, 0, sometimes it's written as an ordered pair, but either should be correct. All right, so your maximum and your minimum. All right, the maximum value here is 5. And again, that could be written as an ordered pair, -5, 5. But your maximum comes from the y value. So 5 is your maximum. The minimum, see, so that'd be 10. That would be -2.5. So your minimum would be -2.5. And if you wanted to write that as an ordered pair, it would be 10, -2.5. But again, the minimum and maximum come from your y value, so that's the number that really makes a difference. All right, you could do the same thing over here. Let's talk through it, but I'm not going to write the answers down for you. So the 0, oh, I didn't do the y-intercept of the other one, sorry. All right, y-intercept. You can see the y-intercept is at halfway between 0 and 5, so 2.5. Okay, and that would be 0, 2.5 if you want it as an ordered pair. All right, so very quickly, the last one here. So your 0 is where it crosses the x, so that would be at -2.5. The y-intercept is where it crosses the y-axis, so at 5. Your maximum value is at 10, and your minimum value is at -5. If you have any questions, please let me know.